Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In the last video we have seen what are image pyramids, and I have told you there are two kinds of image pyramids in OpenCV. One is called the Gaussian pyramid and the other is called the Laplacian pyramid. And we have seen in the last video how we can create the Gaussian pyramid and the Laplacian pyramid. Now in the last video I have also told you some applications of image pyramids, and one of the application of image pyramids is the image blending. So let me show you one example. So here in this code I have two images. One is of apple and other is of orange, and I want to blend or merge these two images. So let me just run this code first of all. So you can see there are two images. First is of apple and other is of orange, and I have also printed the shape of these two images. So you can see the shape is similar, 512 by 512, and orange image shape is also 512 by 512. So here what I want to do is I want to blend half of the orange to half of the apple. So let's say I want to just blend right hand side of this orange to the left hand half of this apple. So how can I achieve this? Now you might say that I can just cut these two images into half, and then I can stack these two images side by side, and I will get the half and half of the two images, and that's how I can just get the result. So let's first of all try this technique. First of all, we are going to just create the half and half of the apple and orange images, and we are going to just stack these images side by side. So let's say I'm going to create the variable called apple underscore orange, and then here there is a method in numpy. So I'm going to just say numpy dot hstack. So there is this method called hstack, and here what I can do is in the form of tuple I can provide the half of my apple image. So apple is the image variable name, and then what I'm going to do is the half of this image, because this image is 512 by 512. So I'm going to just give this kind of expression, colon, comma, and then colon 256, which is the half of the apple image on the left hand side, right? And then I'm going to just do the same with the orange image. So I'm going to just take orange and then colon, comma, 256 colon. So one thing to observe here is I have taken colon before 256 in the apple image, and I have taken colon after 256 in the orange image. And then I'm going to just show this apple orange image, and let's see what result we get when we run our code. So these two are the apple and orange image, and this is the result of adding the two halves of the orange and the apple image. But still you can see this line which is clearly visible, and from this line you can say half of this is orange and half of this is an apple. So in image blending what we need to do is we need to blend this line also. So the orange and the apple image should be merged or blended in a perfect way. So for blending this half apple and half orange image, what we can do is we can use the image pyramid techniques to blend these two images. Now in order to blend two images using image pyramids technique, we need to follow 5 steps. The first step is to load two images In our case, these images are of apple and orange, which we are already doing. So first step is to load these two images. The second step is to find out the Gaussian pyramid of our apple and orange image. The third step will be, from these Gaussian pyramids, find out the Laplacian pyramids. Okay, so we will find out the Gaussian pyramid in the second step, and then in the third step we are going to find out the Laplacian pyramids. Now in the fourth step we are going to join the left half of the apple and the right half of the orange in each levels of Laplacian pyramid. And finally, in the fifth step, what we are going to do is we are going to just join these image pyramids and reconstruct the original image. So let's follow these steps one by one and let's see what result we get. So as I said, first step is already done, which is just loading these two images, and the second step would be to find out the Gaussian pyramid. So let me just write this step: generate Gaussian pyramid for apple first of all, and then we are going to find out the Gaussian pyramid of the orange. So first of all, what I'm going to do is I'm going to just copy the apple image. So I'm going to just say apple underscore copy is equal to apple dot copy. So there is a method called copy which you can use to copy this image. So from this copy, what we are going to do is we are going to generate the Gaussian pyramid. So I'm going to once again name my variable as gp let's say underscore apple, and then we are going to just pass our image which we have copied in the form of list. So I'm going to just say apple copy here. So these steps we have already seen in the last video, how to create the Gaussian pyramid and the Laplacian pyramid of an image. So I'm not going to explain this in detail. If you want the detailed explanation, you can see the last video. Next, what I'm going to do is I'm going to create a for loop, and I'm going to just say for I in our range. So I'm going to use the range function, and we are going to use the 6 levels in this example. So I'm going to provide the range up to 6, and then what we are going to do is we are going to just say apple copy, or you might have named this variable as apple layer also, because we are just creating multiple layer of the apple image for the Gaussian pyramid, right? And then we are going to use the cv.pyrDown method to create the Gaussian pyramid. Okay, this we have already seen in the last video. And now as an argument, we are going to pass our apple copy variable here. And in the next step, what we are going to do is we are going to just append to our gp underscore apple variable, which is our Gaussian pyramid for the apple image, and then we are going to just append this apple copy after we have applied pyrDown method on the same image. So this is just giving us multiple layer of the apple image, right? The same method we are going to apply for the orange also. So I'm going to just copy this code, and then I'm going to just paste this code once again, and this time this will be for orange, and I'm going to just say this is the orange copy, and we are going to copy from the orange image, and then we are going to just generate the Gaussian pyramid for the orange image, and this will be passed here, and also here, and also here, and also here, and this Gaussian pyramid orange will be passed here. Okay, so we have generated the Gaussian pyramid for the apple and the orange. Now we are going to generate the Laplacian pyramid for apple and orange. So this also we have seen in the last video. So I'm going to just comment generate Laplacian pyramid for apple first of all. And to find out the Laplacian pyramid for the apple, what we are going to do is we are going to once again take our apple copy, and then using our Gaussian pyramid. So let's take Gaussian pyramid for the apple, and we are going to use the fifth element of this list. So what we have learned in the last video, how we can find out the Laplacian pyramid. A level in the Laplacian pyramid is formed by the difference between the level in the Gaussian pyramid and extended version of its upper level in the Gaussian pyramid. So this difference we are going to find out in this step. So I'm going to just say this is LP for the apple, which stands for Laplacian pyramid for the apple, is equal to, in the list we are going to just pass the apple copy, and then we are going to use the for loop. So for I in the range, so we are going to take the range, and in the last video I have shown you how to take the range for the Laplacian pyramid. So we want to go from 5 until 0 in the steps of -1, and then in the next step we are going to create the Gaussian extended variables. Gaussian extended is equal to cv.pyrUp. This time we are going to use the pyrUp method, and then we are going to pass our GP apple, which is Gaussian pyramid for apple, and then the index here will be I. In the next step we are going to create the Laplacian variables is equal to cv2.subtract. So there is a method in cv2 which is called subtract, and then we are going to take our Gaussian pyramid for the apple, so GP apple, and the index here will be I minus 1, and the second argument for this subtract method will be our Gaussian extended variable. So we are going to just pass this Gaussian extended variable, and in the next step we are going to just append to our Laplacian pyramid for the apple. So LP underscore apple dot append, and we are going to just append this Laplacian variable to the Laplacian pyramid for the apple. Same we will do for the orange image also. So we are going to generate the Laplacian pyramid for the orange here, and this will be the copy of the orange copy here and here also, and then this will be the GP orange, right? This also will be GP orange, this also will be GP orange, and here instead of LP apple we are going to just say LP orange, and then we are going to just pass this variable here also. So now we have finished 3 steps. One is to load both the images, second is to find out or generate the Gaussian pyramid, and the third step is to generate the Laplacian pyramid for both the images. Now the fourth step is to just join the half of these 2 images. So what I'm going to do is, now I'm going to just create one more variable which will be apple underscore orange underscore, let's say, pyramid is equal to, and also we are going to create a variable called n, and we are going to see later how to use this variable, and then we are going to use the for loop, and then we are going to create 2 variables, one for the first image. So I'm going to just say apple and then lap comma orange lap. Okay, so these 2 variables I'm creating just same as this I in this for loop in zip. So there is a method zip which we can use to zip the Laplacian pyramid 1, which is for the apple, and for the orange also. So I'm going to just say LP for apple comma LP for the orange. And inside this for loop, first of all, we are going to just increment the value of n by 1 each time. So n plus equals 1. And in the next step, we are going to find out the shape of the apple image. So the apple image shape gives us 3 values. First is columns, so I'm going to just say COLS for columns, then rows, and then the third value is the number of channels, and then we are going to just say apple lap dot shape. In the next step, we are going to just create a variable called Laplacian, and we are going to just join the two halves of these two images which we are getting inside the variable apple lap and orange lap. So we are basically doing this step after applying the Gaussian pyramid and the Laplacian pyramid on both the images. So np.hStack method we are going to apply in this step. So I'm going to just write np.hStack, and then as an argument what we are going to do is, we in the form of tuple, first of all we are going to take our apple lap variable, which is this one, and in the square bracket we are going to just write colon comma 0 comma int. So we are going to just typecast the number of columns in the apple shape. So this we got from the shape of the apple index, and then divided by 2. So we are going to just dividing the columns into half, and same we will do for the orange lap. So we are going to just say orange lap in the square bracket colon comma int, and then once again in the parenthesis we are going to just say cols for the number of columns divided by 2, and then colon, as we have done in this step also. And at last we are going to just append this Laplacian variable to this list which we have created. So apple underscore orange underscore pyramid dot append, and then we are going to pass the Laplacian variable here. Now the last and the final step is to reconstruct our image. So let's reconstruct our image. So now what we are going to do is, we are going to once again create a variable called apple orange underscore reconstruct is equal to, this will be the first index of our apple orange pyramid. So I'm going to just say apple orange underscore pyramid, and this will be the 0th index, and once again we are going to use the for loop. So for I in the range, so we are going to go from 1 until 6, and the default step is of 1, so we don't need to give the third argument. And inside the for loop we are going to just take this variable once again, and then we are going to apply the pyrUp method on this. So cv.pyrUp, and as an argument we are going to pass the same variable. So we are going to just apply the pyrUp on this apple orange reconstruct from the 0th index of the pyramid up to the 6th level. And the last step will be to add all the layers. So apple orange reconstructed once again, or reconstruct is equal to cv2.add. So this is also one method which is called add, and here we are adding apple orange pyramid and the reconstructed apple orange image. Okay, so this is this variable which we got by just adding the left and right halves of each level, and then we are just reconstructing this image using the pyrUp method, and thus just adding the pyramid level. So this should be, I think, the index I, right? We cannot just add the list to the image directly. Okay, so this will be at each layer we are just reconstructing and adding it to the image which we got by just addition of this half of the images. Now in the end, let's try to just load this reconstructed apple orange image in the I am show window, and let's hope it works. I haven't checked it yet, so I'm not sure it will work or not. And you can see it's working in the first go, so that's a good thing. So you can see the difference. So this result we got by just stacking this apple and orange image side by side, but this line is clearly visible. But when we applied the Gaussian pyramid and the Laplacian pyramid technique for blending the images, then you can see this line is perfectly blended and this line is not anymore visible. So this is the perfect blending of the orange and the apple image. So this is how you can use the Laplacian and Gaussian pyramids to reconstruct and blend two images together, and result is in front of you, so you can see how it can blend two images so perfectly. So this is how you can blend images using image pyramid technique. I hope you have enjoyed this video, and I'm going to see you in the next video.